Hello again. In the previous video we looked at how to implement optimizations for Hutton's razor, and in this video we're going to show that the optimization we did is actually correct in the sense that it preserves the meaning of the expression. So if I take an expression e and I evaluate it, that's the same thing as first using the constant folding optimization, then evaluating that, right? So we do this again by pattern matching on e, and then just have to remember how these things were defined. We can also see that in the goal. So we see that for numbers we did nothing, so here it's really easy to show that this is the same. So just refl. Bits we also did nothing, so that's refl. And the interesting case really was this addition case where we actually did the optimization, right? So here we see in the goal that we did a width on these two things. So that's why this left hand side hasn't unfolded yet. We have to do the same kind of width in order to make progress here. So I'm going to say width c-fold e or c-fold e prime. Okay, and then I remember that the cases I cared about here was when they were both numbers or something else. So both numbers, then we have to prove something, and if they are something else, then we have to prove something. Okay, so if they are both numbers, then this left hand side has just evaluated to the numbers themselves, whereas the right hand side has actually evaluate is the same, right? So what we have to do here is we would like to look at the recursive calls for e and e prime, but the problem now is that Agda has forgotten that this used to be the same as that. Right, so the thing to do is to put these recursive calls here up into the width as well, so that the connection between this e and this e is not forgotten. So I do that, and then I add two more things down here, p and q. Okay, and I look again what I have, and I see that now I have this connection that n equals t eval of e and q is n prime is t eval of e prime, which is exactly what I need in order to finish this goal, right? So now this is a con2 of plus and p and q, I believe, yes. Okay, so sometimes you have to also add a recursive call as one of your widths, so that the connection is not forgotten between this new n and the old expression, which can be a bit tricky. And here's another tricky thing, because here you would expect that this is just the old thing, right? But here's another place where Agda has forgotten the connection between things, and that's that Agda can't be sure that these two new variables aren't actually the num case. Right? So it's clear for us because we've just not taken the num case, but in a less stateful way, when we're just looking at this clause in isolation, we don't know what clauses has come before it, right? So in order to make progress here, we just have to pattern match on these, so CE and CE prime, and then we're going to see that they expand out to concrete cases that are different from these ones, and then everything is going to be fine. But it's going to look quite awful because we have to consider all these different combinations, but the proof in all of them is always going to be the same. It's always going to be just do the thing, these recursive calls, right? So I'm just going to fill in the same thing everywhere as we would have done if we just had a catch-all. So we're just expanding out the catch-all to be the same thing. And then finally here for the if, here in the optimization we just did it recursively, so we can also do the same thing here. And because there is no cong3 defined in the library, I'm going to be lazy and do it with rewrite instead. So this is c-fold sound of e and e prime and v double prime. And after I've done all of these rewrites, then I can do the rest with REFL. Right, so in summary, in order to prove these things, we just follow the same structure as the original program, including having the same with structure. Right? So because the original program withed on these two things, we also withed on these things. But we have to sometimes include recursive calls, and we need to expand all of the catch-alls for Agda to see that they are not the real cases. And you might say that this is quite horrible, and I would agree. So in the next video we're going to see a better way so that we don't have to do all of this.